Okay. We do have one thing to finish up from our work on Friday. So let me see, I believe that was section 1.5 on multiplication. Is that right?
Yes.
Yeah, thank you. Okay, so section 1.5. Okay, now, we were talking about mental math for multiplication. Okay. So the strategies, multiplying by 2, that was easy. What was the strategy? Just doubles, okay? What about 4? Double twice. For 8, double 3 times. Okay, so not hard there. What's the mental math strategy for multiplying by 10? Put a 0 on the end, right? Nothing to do. Okay, now I did promise that I would give you a mental math strategy for multiplying by 5. So there are 2 ways you can do it. You could take whatever number you were given, cut it in half, and then multiply by 10. Cutting something in half is usually pretty easy. Multiplying by 10, of course, you just add a 0. Alternatively, you could switch those. Okay, so for example, 16 times 5. Let's apply this strategy right here. Take 16, cut it in half. What do you get? 8. Multiply by 10. What do you get? 8, right? Cut it in half. 8. Multiply that by 10, and you get 80. Okay, basically what we're doing is this. The 16 has a factor of 2. Okay, the 16 has a factor of 2. That's why we can cut it in half and get 8. What makes looking at the problem this way useful?
2 and 5 makes 10.
Right, 2 times 5 gives us the 10, okay? That's where cut it in half, multiply by 10 comes from, okay? If you got something that's even, that means it has a factor of 2, right? That's like the definition of even, okay? So you can take that factor of 2, pull it out, and use it with the 5 to make a 10. Okay, so 16 times 5 is 80. All right, now, why would I even talk about 2 ways? Why don't we just do that every single time? Right, what if it doesn't have a multiple of 2? Give me an example of something that doesn't have a multiple of 2. Okay, 9 doesn't have a multiple of 2. So we'll go with a little bit, maybe bigger like this. We'll say 29. Okay, because we know 9 times 5 is 45. That's from our multiplication table. Okay, let's say we had to do 29 times 5. Okay, well, the reason that we got to go to this is we can't cut 29 in half. It's odd. So what we do is multiply by 10, 290. Then cut that in half. Okay, so 290, cut that in half, and let me think here. I guess you're going to get 145. I basically did 300, cut that in half, got 150, okay? But 300 had 10 more than I needed, so each of the guys would get 5, okay? So there's that. Okay, so that's a mental math strategy for multiplying by 5. So we got strategies for 2, 4, 8, 10, and 5, okay? Any numbers that, any math problems that have those numbers in them, we can easily do in our head, okay? And remember, the whole key of mental math is got to look at the whole picture, okay? Don't try to just plug and chug through the computations. You're not a computer. Computers can do it fast like that. But our strength is not doing computations fast. Our strength is thinking. So think about the whole problem and then decide your strategy. Okay, so our next section is about division. Okay, so who can tell me what the key ideas are going to be? Okay, we're going to do some mental math. Okay, there's a pattern. Going to be some other stuff too. So what else? What were some recurring themes in the previous section? Say again?
Models.
Okay, models. How to use the various models to demonstrate the operations. So we'll talk about doing it with the set model, and we'll talk about doing it with the measurement model. What else? What else do you think we would come up with? So we got the models. Starts with an I.
Interpretation.
Right, interpretation. Okay, so models are things you can use to demonstrate the operations. Interpretations are how we make sense of the operations. Okay, so first, division is related to multiplication. And one of the ways we can think about division is by thinking about the quote-unquote missing factor. Okay, so 24 divided by 4 equals blank is equivalent to saying this: 4 times blank equals 24. Okay, so whatever we fill in the blank here should come from what number we have to use over here to fill in this blank. Okay, these two problems are basically saying the same thing. 24 divided by 4 equals what? Well, that means 4 times whatever number we come up with has to give us 24. Okay. So one thing to note here is when we're starting out here, right like that, not this yet. Okay, don't bring the fraction notation in yet. Okay, so division is related. In fact, these are the same thing for adults, but not kids, okay? And of course, division and multiplication lead to these so-called fact families. Okay, so all these four math facts are related into one four-fact family. Okay, so 4 times 6 is 24. Thinking about this right here, 4 times blank equals 24. That number would fill in the blank right there. Okay. Some teacher talk here. The result of a division problem, the answer you get from doing a division problem, that's called the quotient. This number is called the divisor. And this number being divided, that's called the dividend. Okay, notice they have different names because order matters when you're doing division. If we're doing multiplication, factor, factor, product. They have the same name because we can switch the order. Division is different. Order matters with division. Okay, 24 divided by 6 is a lot different than 6 divided by 24. And we'll have to be careful when we say things and write things when we're doing division. Now, when we're making the models, now we have the set model and we have the measurement model, okay? In both cases, division is about making groups. Okay, division is about making groups. Now, there are two interpretations of how we're making these groups. Okay, let's just keep going with this thing here. So I'll write the two interpretations down here. Okay, so the first interpretation that we'll talk about is called the partitive interpretation of division. And the related question is something like this. 24 is 4 groups of what? Okay, 4 groups of what? So in the partitive interpretation, we know how many parts we're going to have. The question is, how big are those parts? So the picture would look like this. I take my entire total of 24, I break it up into 4 pieces, and the question that we're asking is, how big are those pieces? Okay, and the other interpretation is called the measurement model. Comes with a similar setup question, but it's a little different. Okay, in this model here, the partitive model, I tell you I'm going to break 24 up into 4 equal groups. You got 4 groups, now the question is, how big are those groups? What's the other way to look at this? Switch it up, still with 24 and 4. I could tell you how many groups I'm breaking it up into, and then ask you how big the groups are. That's the partitive model. What's the other way? Switch it.
What times 4 equals 24?
Okay, right, so, and now you're thinking about the division as the reverse of multiplication, that's true. I was thinking more about a different way to ask a question like this.
How many groups of 24?
Okay, we're getting closer here. We wouldn't say how many groups of 24, because 24 is our total, so we have one group of 24, that's the whole thing. How many groups of, let's keep using the same numbers that we have up there. Okay, right, so 24 is how many groups of 4? Okay, so same total. Twenty-four is how many groups of 4? So here I told you the number of groups, and the challenge was to figure out how big the groups were. Here we're saying how big the groups are. The challenge is to find out how many there are. Okay, now be a little bit careful when you're drawing the picture. Remember, these pictures should include a question mark. Okay? The model is supposed to indicate what operation you need to do to answer the question. Okay, so the model for this should look like such. We still have a total length of 24. That length is 4. The question mark comes in right here. How many pieces should I have? Okay, so notice I've got little dots right here. You folks in Zoom land, you might not be able to see this on the camera. Sorry if it's a little too small. I got one block that I know is 4. I don't know how many I'm going to have to put in here. To figure that out, I do the division. I do 24 divided by 4. Okay, we know that's 6, of course, but remember, when you're introducing this, this will be to folks that haven't memorized their division facts here. Okay, so we got 2 interpretations. Okay. Tell you what, if you've got primary math 3 with you, take that out. I know I didn't say you were supposed to have it, so sorry about that. Maybe I could project it onto the screen. So if you do have primary math 3 with you, I'd like you to look starting at page 45 here. Okay, so 45, problem 2. For those of you that didn't bring it, or if you don't have it with you at home, I'm going to do a trick. Okay. Okay, we'll switch to the document camera. Okay. So page 45, looking at problem number 2 here. Okay, 4 children were present for $28. They shared the cost equally. How much did each child pay? So which interpretation are we using? Are we using the measurement model? Or are we using the partitive model? Sorry, you guys can't quite see it. The projector is going to warm up and you'll see it shortly. You guys in Zoom land can see it though. So are we talking about measurement or are we talking about partitive?
Partitive.
All right, this is partitive, okay? 4 kids, okay? So the cost is split into 4 pieces, 4 equal pieces. We know the total cost is $28. We want 4 equal pieces that when you total them out give you 28. Okay, so 28 divided by 4 equals 7, and that's how they would do that. So that's the partitive interpretation. Let's go to page 47 and look at problem number 9. Okay, Harry weighs 36 kilograms. He is 4 times as heavy as his brother. How heavy is his brother? Okay, it's more of a multiplication problem, but we can still kind of think of multiplication and division, of course, are related ideas. Okay, so if I were to draw a bar diagram for this, okay, Harry weighs 36 kilograms. Let's say I wanted to draw a bar diagram. How many segments would this have? 4 segments, right? Because it says his brother is 4 times as heavy. So we have a bar with 4 segments. How big would each individual segment be? What would each individual segment represent? Okay, so the answer to the problem is going to tell us that.
Oh, okay.
But each individual segment in the bar diagram, what would that show me? Here, let me grab a pencil here and I'll draw it on here right quick, right? So we decided that we wanted a bar with 4 segments. Okay. Why am I doing 4? Do I always do 4? I mean, the last one had, right, 4 times as heavy, okay? Now, what should each segment represent? Don't get hung up on the division, right? Division and multiplication are related concepts. What should the total thing represent? The weight, okay? So Harry is 4 times as heavy as his brother. How heavy is his brother, okay? So this total thing is 36, right? 36 kg. And then what are we needing to find out? Really? Right? Isn't Harry heavier than his brother? Isn't that what this said? He is 4 times as heavy as his brother.
Oh, sorry, it's backwards. So I can read it.
Oh, sorry about that. Okay, there you go. Okay, so what we're trying to find is this length. Okay, we're trying to find that length, and that will be the weight of the brother. Okay, so are we talking about measurement division, or are we talking about partitive division? I think this is partitive again, right? Because we know how many parts there are. The question is, how big are the parts? For measurement, we'd have to know how big the parts were ahead of time. Okay, let's look at page 48, number 9. Okay, this is another partitive interpretation. We got 16 quarts being poured equally into 4 bottles. So we draw a bar. The total length of the bar is 16. We break it up into 4 parts because they told us that they split the syrup into 4 bottles. Now the question is, how much syrup is in each bottle? So once again, partitive. Come with me to 65. Okay. Let's look at problem number 6 here. Okay, so try drawing a bar diagram for this. Okay, draw a bar diagram. What would the total length of the bar diagram represent? Right, 205, because that's the total of all the muffins that she has. So you start with a bar diagram. The total length represents 205. Now, they tell us she is putting them into boxes of 4, and then it asks how many boxes were there. So what are we talking about? Are we talking about partitive again? No, we're talking about measurement. We know how big the pieces are. The question is how many pieces are there? Okay, so we would do a bar diagram where the total length is 205, and then we have one piece that's length 4, and then the question is how many pieces? So we put some dots there. The question mark would be in there. How many of those pieces? This division problem has something that we have not discussed yet. Right, notice this right here. How many muffins were left over? Okay, so the division is not going to come out evenly. What do we call the leftover part when we do a division? The remainder. Okay, so this division has a remainder. Okay. So, a couple of things I want to talk about here. So the remainder is the amount left over, we know that. Let me switch back to the regular camera. We'll stop this. And we can kill the projector. So, something pretty simple here, 13 divided by 4. Okay? So, if we were to illustrate this with the set model, okay, so 1, 2, 3 groups of 4 with 1 left over. If we were to illustrate with the measurement model, we could do it like that, okay? 1, 2, 3 jumps of 4 plus an additional 1 left over. Okay. We'll do some quick mental math here. So we know division and multiplication are related. So the techniques that we discussed for multiplying by 2, by 4, by 8 lead to related techniques for dividing by 2 and 4 and 8. Okay, so you want to multiply by 2, you take whatever number you have and you double it. You want to divide by 2, what would you do? What's the opposite of doubling something?
Take away half.
Right, cut it in half. Okay, so you want to multiply by 4, you double it twice. You want to divide by 4, what would you do? Cut it in half twice. Okay, so start with 84. We cut it in half. What do we get? 42. Cut that in half. then we get our final answer of 21. Okay, how about 4164 divided by 4? Looks big, but it's not that difficult. Cut that in half, what do you get? 2,000, right? 16, cut that in half, what do you get? 8, so 2, 0, 8. Cut that in half, what do you get? 2. Okay, so 2, 0, 8, 2. Now I've only cut it in half once, so I've got to cut it in half again. Okay, cut that in half, what do you get? 1. Cut 0, 8 in half, what do you get? 0, 4. And cut this in half, you get 1. Okay, so dividing by 4, cut it in half twice. Divide by 8, cut it in half 3 times. Okay, I want you to think about the method for dividing by 5. Take the technique for multiplying and try to reverse it. Okay, look at the steps we did and reverse those steps. Okay, so I want you to read through section 1.6 of elementary math for teachers. It starts on page 32 and goes to page 36. Okay, so I'd like you to work on 1 through 6 on page 36. Okay, be ready for a quiz over that material on, well, for you guys Friday.